Hi, everyone. I guess you can hear me well. Thank you for joining. After a lunch hour, it's usually the toughest hour to keep awake. I wish I can have espresso service for all of you here. I will appreciate that myself as well. Hope the conference has been productive so far. Today, we will be sharing a case study with you. In fact, this case study with anti-money laundering is the number one use case that we are seeing with the financial services and banking customers. Some of the keynotes also share the experiences how, for example, machine learning is used for fraud detection. Definitely the quality of the data and how scalable how scalable and high performance the algorithms become very relevant in the case of anti-money laundering use case as well. Just a quick introduction. Who am I? I am Tendio Chu. I am the Chief Technology Officer for SyncSort. And I have been in the data management software business over 25 years, but I always remember LinkedIn CEO once said that it's not about 20 plus years experiences, it's 21-year experiences, as the technology stack always evolves very fast and we keep learning about new ways of solving problems. So today's session, we will basically focus on the business problem that we are trying to solve. And the business problem is detecting and preventing money laundering. And the challenges about machine learning is definitely a very good way to address this business problem. However, it's not easy. There are challenges around that, and this is a real use case. This is a real case study. We cannot share the customers' names here, but this is a joint customer of us running on Hortonworks data platform as well. And we will also share the solution that this particular global bank came up with addressing these challenges and how they solve the business problem. So what is money laundering? If you are watching Ozark on Netflix, you are very familiar, I assume, or if you are somehow associated with the financial services. Money laundering is basically the process of showing money originated from, as a result of criminal activities, to make it look like it's legitimate, coming from a legitimate business activity. And it's very important for banks and to really show that they actually have the processes and practices in place to meet the requirements that Bank Secrecy Act requires. BCA has some requirements in terms of the minimum standards the banks have to meet and detecting and reporting the activities around laundering, securities fraud, and also market manipulation. And in fact, if you were in the keynote this morning, you might have seen Kevin Slevin's excellent presentation on how the markets were manipulated by an inaccurate Associated Press announcement about the explosions in White House, right? These are really happening on a daily basis. And every country has similar, however, separate regulations. The US, UK, South Africa, they have some ways of having regulations around these. And usually the banks are also required to keep the data up to 7 years, data that can be kind of related to these tracking these activities. In general, I'm just giving the definition of the business problem to make sure that we understand, because the challenges around detecting this is somewhat related to how the steps of laundering happens as well. So in a typical scenario, there are 3 steps called placement, layering, and integration. And in the placement, the goal is ultimately to sneak that dirty money originating from the criminal activity to the financial systems. And this happens in the form of usually, for example, cash purchase, a large cash paid purchase of some goods, or it can also happen through a foreign exchange. In some countries, the regulations are not as strict, so it might be something that's shown as if an investment was made in a foreign country. Some examples. And then the layering. Layering is really the one that's kind of the important one, because it also creates the associated challenges in terms of detecting. Because ultimately, in the layering step, the criminals try to make the activity as not traceable as possible. So the layering implies that that money changes hands and goes through several different transactions, and might be put on different people's names and different locations in different countries, having that money and cash flow through the monetary system as if it's going through very different hubs. And that layering also makes it very difficult to detect the activity. And integration is basically having that money come to the legitimate system. It's as if it's looking like it is originating from a legitimate business and coming from a legitimate activity. So this case study is from a very large global bank, and this is a joint customer of Hortonworks and SyncSort. And their challenge was really to have the anti-money laundering running in a very scalable and high-performance way. And the challenge for scalability was coming from the fact that they had massive amounts of data sets to analyze. And also they had very disparate data sources scattered across the different data centers. Yesterday and today we heard, Rob Bearden, CEO of Hortonworks. This morning we also listened to the keynotes. It's very important when we are working with the next generation modern architectures, data architectures, it becomes also very critical. How do we tap into the data stores that are already existing in the organization? And if we look at banks, and this is true for any of the financial services, large financial services and healthcare as well, and insurance companies. But when we look at banks, pretty much all of the transactions, the key mission-critical data, the ATM transactions, etc., often are kept on mainframes. So in this particular case also, they had data on Oracle, SQL Server. Some of the data is kind of coming through the cloud, mobile transactions, and they had to be able to refer to that customer critical data that was already on the mainframes. So that created a bigger challenge, because this organization is trying to really create the modern data architecture and this massively scaled analytics environment, yet they have a lot of data stores, including legacy data stores, and mapping those data formats into something Hadoop readable formats became a challenge. So requirements were pretty basic. Obviously, it has to be secure, and it has to have visibility to data, because visibility is becoming more and more critical. We are talking about in the platform as a services, for example. In this conference, the highlight is about being able to have hybrid environments, multi-cloud environments, and these platform as a service environments, data as a service environments are really becoming quite broad and complex. So it was important to create that visibility as the data goes through multiple platforms on-premise and in the cloud. They did not have cloud implementation yet. However, the bank required everything in terms of the applications to be cloud ready, because they do have plans at some point to start having at least a private cloud and public cloud combination, a hybrid. And the consolidation of the data, delivering the clean data for the analytics was really a #1 requirement, because bad data produces bad results. We heard that from Rob Thomas yesterday. Bad data can be parallelizing. He expressed it very well, actually. As a kind of, in addition to this use case, they also had a requirement. That requirement was having an unmodified version of the data always kept for compliance archive use case. And machine learning is really a great way to defend against and detect these kind of activities with anti-money laundering as well as fraud detection. Because detection of patterns across massive data sets is a key. And in this case, detection of patterns across massive data sets that are coming from transactions, money transfers, ATM activity, and being able to track those data patterns and identify the spikes, identify the outliers, and be able to find the relations between multiple data sets across these data sources is really critical. And machine learning algorithms, deep learning algorithms are very well fit here, solving these kind of problems. Human feedback loop is obviously critical because one of the key things is preparing the data and having the clean data set really ready for this kind of analytics. And if the data scientists are not spending 80% of their time doing that preparation of the data and integration and cleansing of data, then they can really focus on the insights, the real answers, and the questions that they are trying to ask, identifying the patterns. The human feedback is a critical part of this because then they can really identify the false positives and improve the data models and overall models for the machine learning. The bank doesn't, this has to be a systematic thing, automatic as much as possible, so that there's no reliance on manual, the set of thresholds and predefined rules, because that really slows down. One of the things is that to be able to have this detection happening on a timely basis as close to real time as possible. Machine learning is the best defense? Yes. Sure. En masse. That was their, obviously, there's a minimum viable product, proof of concept kind of happens initially. But once that's kind of in place, the training of the models is really tapping into the massive data sets, the historical data sets that they already have. So, machine learning is the best defense. However, still, it's not as easy because there are really multiple steps into this as we have seen. So one of the biggest challenges was really being able to access scattered and diverse, difficult to access data sets. And this included data sets that were kind of locked on the mainframes, and this project was owned by the data lake and big data analytics teams. So we often see in the organizations that there's a little bit of access challenge also with the mainframe teams that may own some part of the data and legacy systems that may kind of protect data, and the analytics teams are trying to access that data. So they are really trying to have tools that will make it as easy as possible and less intrusive to the legacy system, so they will not get that objection. So we quickly onboarded the data. We, in fact, have tools really focused on having all enterprise data, all including enterprise data warehouse architectures, relational data stores, semi-structured data that can be coming like vSAM files, mainframe and IBMI data stores. So in this case, Oracle DB2 on mainframe and the SQL Server were the first ones. And we used Data Funnel. This is a web-based tool. With the click of a button, you can point to a database and really have hundreds, thousands of tables directly ingest them to the cluster. They wanted to keep this data in Hive on HDFS, Hive on HTTP. And they used actually a data funnel to do auto mapping of the metadata as well. Because one of the benefits of using a tool here to accelerate and create that agility in terms of having and mapping a particular data type on mainframe to Hadoop recognized format becomes a challenge for the engineers. And it's not only the skill sets on the new stack, we are also requiring now skill sets on the retiring old stack. So it's a combination, it multiplies the skill challenge. So we use the data funnel, and in fact, this is part of our joint solution offering with Hortonworks. Hortonworks and SyncSort have ETL onboarding, Hadoop ETL onboarding for quickly onboarding data and ETL processes. So we used the SyncSort data funnel to onboard the data as well as join those data sets to prepare it. And the next challenge was, and these are not kind of sequenced, but they are their cleansing step. Basically, as we are integrating the data, we want to make sure that we are also getting rid of the data that's not going to be relevant. There's a recent Harvard Business Review article on this in terms of the impact of bad data for the machine learning. So if your data is bad, your machine learning tools are useless. However, there's kind of a multiplier impact, a multiplier effect here, because we are training the algorithms with the historical data. So if the data is bad, we are training the algorithms with bad data sets. And then we are using those trained algorithms to kind of make predictions or recognize patterns. So we are multiplying the impact of really bad data into the results. It's very important. Data cleansing and quality becomes very critical in general data pipeline feeding in AI-based or machine learning-based analytics. I mean, this is not something new. Anybody in we computer scientists know that the garbage in, garbage out is really a rule of thumb. And we used the data quality for big data solution, which is basically allowing the data engineers create the flows for quality, pointing out to the sources, and deploy that in the distributed compute environment and take advantage of the HTTP. And the third one, and this one is actually probably the most critical one for this particular use case, because it's also the one of the very difficult tasks to perform in a distributed compute environment. The entity resolution and customer identification. What is entity resolution? So when we are looking at massive data sets, and we talked about layering, right? When the criminal activity, the criminal is trying to have that layering to hide where the data has been through and multiple monetary transactions. There is a lot of activity that happens that the algorithms have to detect across and find the relations across multiple fields, multiple entities. And ultimately, we are comparing everything with everything else. And that's a massive compute intensive operation. And that's, you can think of like in logic transitivity relations almost, like we are finding every relation between the fields and matching and identifying what fields might be related to each other, because then we can use that to identify the single customer and say, okay, for example, here, if we have the record for the customer service and then the web login, the transfer, money transfer happened, somebody purchased something, an ATM transaction happened. If we look at these, we may have Bob documented in many different ways with Rob Smith, Mr. Robert Smith, etc., and in different countries by different addresses. So in this kind of a scenario, it's very rare that we will have an exact match. So using fuzzy matching, using scoring algorithms in terms of defining the thresholds, how are we going to kind of score the distance between the fields, and the data between those fields become really important. And the multi-field matching also becomes important across these. Not looking as just name, but matching across multiple fields, and also matching across arrays. Like, for example, the address will be an array here, because it's multiple words with 3 David Drive versus 3 David Drive number 16, or just number 16, finding those relations across the records. And answering the questions, are these two accounts are potentially for the same person or for the same business? Because once we answer those questions, then we can say, okay, it's ultimately, this is a potentially a single business or single customer, and they might be relating to all of the activity that's happening. And of course, the next challenge is related how real-time we would like to have this happen. Of course, we are not going to do this once a month. The transactions keep happening every time somebody transfers money or an ATM transaction happens. We want to capture that and feed into combine the data sets that we already created and prepare and start really leveraging that change data in the data flow as quick as possible. And we used, again, SyncSort has changed the capture as part of the Hadoop data integration offering we have, and we capture log-based change from pretty much all databases. Teradata is not there because Teradata doesn't have log-based change, but we can have the delta calculated, obviously. And the bank had a requirement. It's one thing is that feeding this change data coming from the new transactions into the data lake for the analytics. They also required us to create a model that we can directly write to Kafka as a data bus, because they wanted to feed this to downstream applications in real time as well. And then the last but not least is once we create this data flow where we are really ingesting the data, integrating from multiple sources, cleansing and preparing for the downstream analytics and performing to entity resolution and matching across massive data sets in a scalable way, every highly regulated vertical requires ability to track what happened to data. Lineage is becoming even more critical because we have so many different data stores now and multiple platforms. And Atlas gives visibility on the HTTP platform. As we were accessing data from mainframe, Oracle, SQL servers, mobile transactions, and integrating that and ingesting that to the cluster, reformatting the fields so they map to the Hadoop recognized formats, we keep very granular level, field level information, where the data originated, what kind of transformation the data has gone through, and where did the data land. We have integration with Atlas. In fact, in the Expo Theater, we had 2 demos with the Hortonworks today showcasing that Atlas integration for Lineage. We also published this through the REST APIs and can also publish into Cloudera Navigators in the case of a different Hadoop stack. But we are pretty tightly integrated on the Atlas. And this shows the lineage. Atlas already is having visibility into what happened in the cluster, and SyncSort publishes the lineage from what happened to this data before even landing in Hive tables and before written to the Hadoop formats. So we publish that through Atlas and create that visibility. So as a result of that, the solution we came up for the bank really includes creating that single record for the customer identification, having the cluster native data verification, enrichment, having the multi-field entity resolution, and running this in a scalable way using SyncSort's integration and quality tools with HTTP Spark. And we also published the end-to-end lineage through Atlas, and the customer was running queries through HiveQL in addition to using other downstream applications for analytics and reporting purposes. Benefits: they were able to do this in a massive scale, and they were able to meet the requirements of the BCA and also the Financial Conduct Authority. They were able to really meet the requirements and have near real-time implementation. That's all I wanted to share. Who is SyncSort? We are a data management company. Our specialization is really connecting the existing infrastructure with the next generation analytics platforms. You can come to our booth P2 and see a demo of the products, both for ingest and change data capture and quality. We have offices globally, and we have a very close partnership with Hortonworks. In fact, the Hortonworks resells us for ETL, and we have a joint solution for ETL onboarding. Thank you for attending my session, and it's open for questions now.
How did you
okay. Thank you.
How did you reduce the false positives?
Okay, so the question is, how did we reduce the false positives? I mentioned about the human loop feedback. So the bank had data scientist team. So as we were finding these potential candidates for the activity, potential detects, that the data science team was kind of going over them to do a pass. And if they noticed, they did a sampling basically. In that sample, if they noticed there were false positives, we will basically tweak the model for the training and then rerun. So it was a iterative process. It didn't happen like out of the gate, and it's a continuous improvement process in general. That's what we are seeing in the other institutions as well.
So, like, you are able to reduce down false positive to 50%, 60%. Like, what is the ratio about real fraud and the false positive?
So the false positive, I don't have the exact, but the data quality part I can give pretty much on the quality side. When we are doing the matching and cleansing, we really have over 90%. We have very close to 40 algorithms we use for the matching for quality. So once you have that level of clean data going into the model, the starting point becomes a better point to start with. So I don't have the exact number, and I don't want to just throw a percentage here, I don't not a credible number.
Thank you.
Thank you. Any other questions?
So you mentioned about the integration to the data funnel and for the CDC. Is it like a homegrown application, or are you with a third party?
No, this is SyncSort. SyncSort has products. Data Funnel is SyncSort's product. Actually, we are demoing is in P2, boot P2, and it is designed to make it simple onboarding massive amounts of data to the cluster. So it's a data integration product, and we are making ingesting data as easy as possible when it is coming with like hundreds of tables, and change data capture product is also SyncSort's CDC product that runs in the Hadoop.
In your CDC product, will also work on SAP environment?
CDC currently is not working with SAP. However, if that becomes like a requirement, we are usually seeing Oracle SQL Server, Teradata, but Teradata doesn't have log-based capture still. We see Netezza, but the top ones are really DB2 on mainframe or IBMI. vSAM from mainframe, we see a lot, especially with financial services and insurance verticals, and healthcare as well. And Oracle SQL Server are the other ones we often see. SAP, we have SAP connections and SAP HANA connections as data sources, and we work with them, but we are not doing log-based capture with that. Yes, please.
So for you, are you able to replicate tables that logging is not enabled on?
Yes, we can ingest data from any sources. And one can do change data capture in 3 ways. One, keeping the data, the current data and the past data, and running basically a process to transformation to compare them and identify the changes. So that's actually pretty scalable. You can have the past data and the current data in the cluster, especially cluster enables that, compare and identify the changes. Now it becomes challenging if we are talking about like on a daily basis 100 terabyte of data coming to the cluster, right? Because we don't want to kind of have the full snapshot. The second way is trigger-based change capture, which usually is not preferred because it's not performing well. And the third one is log-based capture, directly have the change from the log and make the updates to Hive in the cluster. So we do all 3. We prefer not to do trigger-based as much as possible. For example, for Teradata, when there is no logging available, we will basically have the snapshot of data and capture the change. For everything that you can have the logging available, we rely on the log-based. And one of the actually important things that I didn't mention, resiliency becomes very important with the cluster environments, also making it cloud ready. So being able to auto start when something fails in the network, for example, connecting the cloud, and having that resilient change data capture becomes very important, and we guarantee that. Any other questions? Yes, please.
So you talked about CDC and then somewhat event-based. You mentioned writing target to Kafka. Does the engine tool allow you to kind of be in a non-batch disposition, kind of an always-on event-based kind of mode?
Yes, the data replication for CDC is real-time, and we feed continuous to Kafka. If it is on Amazon, we do the same with Amazon Kinesis, but Kafka is something that we are seeing like a parallel to data lake, pretty much becoming a standard now. So that ability becomes important. Any other questions? Thank you, and please stop by the booth if you have further questions or if you want to see the demo. Thanks for attending our session.